Brandon Lewis here of Embedded Computing Design, and it's day one of CES 2018. We're already really burnt out, but we decided we could stop by the Infineon Technologies booth, and I'm here with Michael Armentrout, who's the Regional Business Development and Marketing Manager for Chip Cards and Security at Infineon. How are you doing, Michael?
Good. How are you?
Doing pretty well. Like I said, it's a little tired already, and I still have 3 days to go, but we'll get through it. One thing that we're looking at here is smart home security, and this is based off of the Infineon Optiga TPM, which is a TPM 2.0, right, from the Trusted Computing Group. And the demonstration that he has is pretty comprehensive. It shows a bunch of connected devices here and how they're each being secured, and the entire system's being secured from a potential cyber attack or hacker. And Michael's going to walk us through it. You want to show us what's going on?
Yeah, sure. So basically what we're showing here is a range of devices. So this is a gateway that's using our Trusted Platform module, then talking to a number of nodes within the home that are using various products within our Optiga Trust product family. So in this case, for example, this is a Bluetooth module that's then using an Optiga Trust product and doing a mutual authentication between the node in the home and the gateway. So validating that this node is correct, it has the correct credentials, as well as the gateway itself is correct. We also have our Optiga Trust products here, as well as doing a local mutual authentication. This is one in a washing machine that is connected to the gateway, but is also connected to cloud service. So in this case, it's an AWS service. So validating that the service it's talking to is correct and the device itself is correct. So this can be used to do mutual authentication between the device and the service, as well as to authenticate updates that come down, make sure that there's been nothing compromised on the device itself.
That's really cool, but one thing that I ask myself, and I'm sure a bunch of manufacturers of consumer electronics ask themselves, is why do we have to pay for this? Are people really going to be sitting here trying to hack this network? Is that the case, or?
Yes, so there's a couple different things that we're trying to protect against. One would be the case where you have people locally trying to break into the home, either the home network or maybe the home security itself. In this case, we have part of the demo here is showing a hacker trying to do that with a Bluetooth transceiver. They're able to connect into the Bluetooth itself and get access to that, but without the security chip, without the credentials on the device, the system will stop them from connecting.
So here we can see the hackers trying to authenticate right now.
Hackers, yeah, they tried to get in. The authentication failed, however, and so the system is able to see that a hack was tried and blocked it. Another typical attack, though, would be over the network itself. So most devices that are sitting in a home or in any kind of network have over-the-air update capabilities. And so one common attack is for hackers to come in, use those over-the-air update services to try to load in malicious firmware on the device, turning the device into a botnet or otherwise getting control of the device. And so with our devices, we're able to check the credentials of those firmware updates, make sure that those are legitimate before the device activates those, and also monitor the device when it boots up and make sure that the firmware that's booting is correct and legitimate.
Great. One last really quick question. How much memory does this take up?
So our chips themselves come preloaded, so they come preloaded with everything, including a lot of the keys and everything that the consumers would need. On the microcontroller, it will vary based on the product, and so at the lower end on some of these, it could be 10 or even lower kilobytes of memory that's required on the host microcontroller, and it does depend on then the functionality that you're looking for.
Well, that's some good stuff. This is Brandon Lewis here at CES 2018. That was Michael Armentrout of Infineon Technologies. Less than an excuse to leave your IoT insecure. Have a good one.